Everybody, let me define embedded system. Embedded system is an electronic or electromechanical system. That means there could be electronic components and devices, there can be circuit as well as some moving parts. So put together, embedded system is an electronic or electromechanical system. It can be separate. That means it can be a single system or it can be a part of another system. Then it is defined for a specific purpose. That means there will be one single purpose for which embedded system will be designed. And it is the combination of hardware and the firmware. What do I mean by firmware? It is the software being burnt into a permanent or a non-volatile memory. That is what the definition of an embedded system. We will see the examples of embedded system. Some of the examples are household equipments, telecommunication equipments, household equipments like oven, washing machine, telecommunication equipment like cellular mobile, satellite communication, optical fiber communication, some of the medical equipments, industrial control equipments, automobile equipments, consumer products, defense related equipments. These are all the examples where we find applications of embedded system. Example for an embedded system, to call it as an electromechanical system used for specific purpose and all, is the washing machine as an example. The washing machine consists of hardware, software, mechanical, to call it as a electromechanical system. Hardware consists of buttons, display, buzzers to alert the user that clothes washing is completed or something like that. Then electronic circuitry, which controls the electronic system of the hardware. Then the software will have the memory chip, wherein there is a software to drive, control and monitor the operation of the washing machine. Then coming to the mechanical parts, the chassis itself, the external cover itself is one of the mechanical component. Then the internal parts which will allow water to inlet and water to exit and all. Then the movement of the washing machine part which revolves in different way to clean up the clothes. So these are all the hardware, software and mechanical components of washing machine. To call it as an embedded system, which is an electromechanical system for a specific purpose. Let's go to the history of embedded system. Apollo Guidance Computer AGC was developed first of all by Massachusetts Institute of Technology Lab, which involved 4 kilowords of RAM, 256 words of RAM, and it had 1.024 megahertz of working frequency. It had very less number of instructions like 11, and it was integrated with 5000 gates or transistors. User interface looked like a calculator. That means one display unit followed with one keyboard unit, which made the user interface for the AGC. Then the first mass production of AGC called as Minuteman 1, which was a missile control system, developed and brought out in 1961. Japanese came up with a Busicom embedded system, which looked more like a calculator in 1971. It was a microprocessor based one, and it had Intel 4004 IC as its processor. Let us see the characteristics of embedded system. First characteristic is application and domain specific. That means embedded system is designed for a particular field, for a particular application, not other than that. It cannot be worked for other than the application and sector or the field for which it is designed. reactive and real time. That means to say it can receive the atmospheric conditions as input and take up the corrective measures. Operation in harsh environment, wherever human friendliness is not there in an environment like temperature being very high and other harsh conditions, there embedded system should find suitability to work in. Distributed, that means embedded system can be a part of another bigger system, wherein this embedded system works as a separate accessory which has to coordinate with other units in a bigger system. It should be of small size. That means embedded system should have a portability. It should be easy to carry from one place to another. Power concerns, that means it should utilize less power, as well as power dissipation should be less. So these are all the characteristics of an embedded system. Let us see the purposes of embedded system. The first purpose is data collection, storage and representation. Data collection in the sense it should be able to receive the inputs from the atmospheric conditions or in the surrounding, like data acquisition it is said. Storage in the sense how to organize that in the memory, and representation means whether is it to be required from analog to digital conversion and all have to be done. So like that, data has to be received, it should be organized, and in the proper form it should be represented. That is the first purpose of an embedded system. Data communication. The purpose of embedded system should be for the data communication, like wireless communication such as Wi-Fi, Bluetooth, Zigbee, etc. and wire communication such as Bluetooth, TCP/IP protocol kind and all. Then data processing. Data has to be processed in the sense it should be received and maybe coding required, maybe modulation required while sending and all. So data processing is also a purpose of embedded system. Monitoring means it is the display system. For example, if ECG is connected to the patient, the graph will be continuously monitored on the display system. So monitoring is also a purpose of an embedded system. It is not enough if you just monitor. You have to control maybe. For example, if the temperature of a room is more, then the embedded system has to take up control measure, like it has to increase the controlling effect by speeding up of the fan, etc. Then ASIC, application specific integrated circuit, is the purpose of an embedded system, so that a customized IC is designed and ready to use is provided to the user, wherein the space occupied by the IC will be less and power requirement will also be less, and the IC will be more economical. So these are all the purposes of an embedded system. Let's go to the classification of embedded system. Based on generation, that means based on the advancement, there are first generation, second generation, third, fourth generation, etc. Based on the complexity, that means the kind of microcontroller as a core which is used, based on that there are different classifications such as small scale, medium scale, sophisticated scale, wherein the microcontroller could be 8-bit, 16-bit, 32-bit, 64-bit, like that. As the complexity of microcontroller enhanced, based on that, complexity of embedded system will be small scale, medium scale and sophisticated scale. Based on the performance, for example, real time in the sense it should work in a fixed time interval. It has to act within the span of time. There are two types of real time, such as soft and hard real time. In soft real time there is a bit of flexibility, but in hard real time the time limitation is very narrow. The examples for real time based embedded systems are traffic control system, military and medical type of systems are the examples for real time. In coming to the standalone, here it will work independently or individually or separately. The examples for standalone are MP3 players, ovens, calculators, etc. Then coming to the network, this should work within a network, within a web. This embedded system has to work. It should be connected among a network. The examples for network based embedded system are home security system, ATM machine, card swipe machine, etc. And then coming to the mobile, it should provide portability. That means it should be able to be carried from one place to another very easily. So the examples for mobile embedded system are MP3 player once again, mobile phones and a digital camera. These are all the classifications of embedded system. Now let's compare an embedded system with a general purpose system. An embedded system is designed for a specific purpose, whereas general purpose system is of course general. It can be used in any ways the user want. Embedded system will have a specific hardware and the operating system, whereas general purpose can be a general hardware and an operating system. Embedded system, because it comes integrated, of course it uses less power. General purpose is assembled one with all the units, it requires more power. Here the program is written in the non-volatile memory, so the program is not altered, whereas in the general purpose program can be altered. Whereas in the embedded system, the embedded system will be used by a user, whereas a general purpose system will be used by a programmer. Embedded system is microcontroller based because microcontroller enters or burns its program into a non-volatile memory, whereas microprocessor allows the program to be written in RAM. So general purpose will be MUPI based. Embedded system will be a part of bigger system or an individual system by itself, whereas general purpose can be a standalone, a separate system. Embedded system very harder to develop. That means a designer has to be there to come up with the development of an embedded system. General purpose system can be easily developed by assembling separate units. Application of embedded system are robotics, defense, avionics, etc. Whereas the examples of general purpose is supercomputer, desktop, laptop, mainframe computer, etc. are the examples of general purpose system. Now let us see the quality attributes of an embedded system. There are two types of quality attributes. One is operational, the other one is non-operational. Operational in the sense when the embedded system is in use during the working condition, what are all the quality attributes? Quality attributes in the sense what are the special characteristics of embedded system? What are the characteristics, nature that is expected from an embedded system during the operational condition? First one is response. The quickness at which embedded system responds. That means the speed at which it gives the response. Throughput is the efficiency of the embedded system. How efficient an embedded system is. Reliability. Reliability means how much you can depend upon that embedded system. Then maintainability, there are two types. Schedule in the sense periodic maintenance. Unexpected in the sense if suddenly some accident or some wear out occurs, then the maintainability that is required. And then security. Security will involve three types of security. One is confidentiality, the other one is integrity, and the third one is availability. Confidentiality is the information being not reaching to the unauthorized person. That means it should not be disclosed. Integrity in the sense the unauthorized person should not be able to alter, should not be able to modify the system. Availability in the sense the unauthorized user should not get an access to that embedded system. Then finally the safety. Safety is the avoiding of a damage or the accident that might occur to the embedded system. So these are all the quality attributes of an embedded system when it is in the working condition or when it is operative. We shall see the quality attributes when the embedded system is non-operational. That means when the embedded system not yet to be used, before it is being put to use, what are all the quality attributes or the special characteristics that are to be expected from embedded system. The first non-operational quality attribute is testability and debugging. Before the embedded system handed over to the user or before it is being operative, we should be able to thoroughly check. That is nothing but cold checking, what we call it as. Hardware and software both have to be properly checked. So embedded system should allow us to do the quality checking before it is being put to the user or given to the user. Evolving ability. Before it is put to the use or when an embedded system is available, we should be able to evolve it. That means we should be able to improvise it. If we find any deficiency or addition that is possible, such embedded system before it is being operational should allow us to improve upon its ability if required. Then per unit total cost. Then when you sell it out, it should find easy marketability. That means it should be able to be affordable or feasible with respect to its quality. So per unit total cost should be lesser. Time to prototype and market. Once you design an embedded system, you will go for mass production and producing it industrially and put to the market. So time taken between designing of an embedded system and bringing it to the people or bringing it to the use should be very less. So these are all the quality attributes of embedded system before it is being put to use or when it is not operational. Now let us see the applications of embedded system. There are many applications, and more than this also there could be applications. Importantly, we have got automobile and communication. In automobile and communication, we have got entertainment and media in a car. We can have a video player or audio player, MP3 player like that in a car. Engine safety, e-commerce, robotics, wireless communication, mobile computing and networking. These are all some of the examples coming under the automobile and communication applications. And in the second application, smart cards, missiles and satellites. Smart cards, one could have an identity card where there could be codes. By scanning those codes, the individuality or the capacity of that person can be understood. Like that for missiles in war applications, then satellites in applications of communication. So smart cards, missiles and satellites will have examples of communication, security system, telephone and banking, defense, aerospace. These are all the examples coming under the applications of smart cards, missiles and satellites. The third one, peripherals and computer network. Peripherals and computer network will have displays or monitors, networking equipments, image processing, printers. These are all the examples of embedded system coming under peripherals and computer network. Then coming to the consumer electronics, that is used for daily life of a person. Digital cameras, set-top box which can be used for accessing of cable signals. Then HD TVs, high definition televisions and DVD players. Such of those are the applications coming under consumer electronics. Then home appliances, oven, washing machine, food processor, like that come under home appliances. Then automotive electronics, the electronics which does not require the interference of human, on its own it works. Such automotive electronics will have examples such as security system, power train, that is the train which have auto locopilots, without the human locopilots, on its own it goes around or moves around. Then military or aerospace examples: radar communication, sonar, weather systems, flight control systems. These are all the military and aerospace applications. Interesting application of an embedded system is the smart running shoes. It is a case study, and the running shoes is developed by Adidas shoes making company. It adopts all effect sensor. That means sensor will be one end of the cushion, magnet will be on the other end of the cushion. So in between this Hall effect sensor and the magnet, the cushion will be there. Based on the man who is wearing his body weight and the surface on which he is running and the speed at which he is running, the gap between the sensor and the magnet will vary. That means the cushion that comes in between magnet and the sensor will vary its size depending upon the man's weight, running style, speed and the surface and all. So you can readjust the cushion. You can either make it tight or allow it to elongate or allow it to relax. So you can adjust the cushion effect by the concept of all effect sensor. Sensor will be on one side, magnet will be on the other side between the cushion. When the cushion size varies, magnet might either come near the sensor or go far from the sensor, thereby different Hall voltage is produced. Based on the Hall voltage, the input is given to the microprocessor. The mini microprocessor will work upon the values that are input, and it uses the motor, a small motor, to readjust the tension of the cushion. It either reduces the cushion gap or increase the cushion gap as per the requirement of the comfort. A steady DC supply is used to drive the all effect sensor. So that is how smart running shoes using all effect sensor concept is designed.